Hello, in the last videos we discussed many questions on DSU. Let's discuss the next one. Here is the question, read it and give it. There is another tree with 10 nodes labeled from 1 to n. You are given integer n and edges of length n minus 1 indicates an edge between u and vi. Return the number of valid paths in a tree. A path is valid if there exists exactly one prime number among the node labels in the path from A to B. So it is given that we are given a tree. We want to find the number of paths with exactly one prime, and the constraints are n is up to 1 if I. So let's say this is the original tree, and for this, what is the answer? What are the number of good paths? We should have only one prime, so it can be 3 1, it can be 2 1, it can be 2 4. That's it, because it can be 1 to 2 and 1 to 3. From 4 it can be only 4 2, and from 1 it can go to 2 and it can go to 4 also, because in this whole path there is only one prime, which is 2. So now let's assume we only have one prime, because it is given that we should have only one prime. So for now, let's assume the most basic one, which is what if the tree has only one prime? Then how can we find the answer? So this is the root, right? Let's assume this is the prime node. How to find number of paths passing through this? So instead of rooting some other node, let's just try to root at the prime node, because we assumed only one, and let's root it at the prime node for now. So now is it easy to find the answer? It is easy, because let's say this is the root node, which is the only prime node in the tree, and the subtraces of every child are A, B, C. And now what will be the answer? So the number of paths passing through node will be, for example, it should start from one child and it should start from other child, end at other child. So this is the root node. So the number of paths containing it would be the path should start from any of the node in the child, and it should end also in any of the other child. So what are the number of ways? For example, if you assume that this is starting from this, the number of paths would be A into B plus C, because starting from this and it should end at any other leaf, any other subtree, so it will be A into B plus C. For example, if the path is starting from this, then what will be the answer? It will be only C, because if we try to recount A again, then there can be double paths. So we can think it of two ways. For now, the most simplest thing is, for every node, for every subtree, multiply the size of subtree and into size of all the other subtrees, sum of all the subtrees, so that it will return the number of paths starting from that node and ending at any other subnode. So it will be A into B plus C plus B into A plus C plus C into A plus B, because A into B plus C, B into A plus C plus C into A plus B. So but this will have overlapping one, because for example, let's say we have two nodes in A and other node in B, one node in A and one node in B. So we are counting this both in the first part and second part as well. So this will lead to double path. So simply we can return answer by 2. So in a simple way, if the prime is only 1, then we can root it and we can find the subtree sizes by DFS, and then we can return the answer. But this is not this way. We can have many paths, many primes. So now let's try to do the same dry run. What if we have more than one prime? So the nodes that are marked red are primes, and the ones are blue. The blue are non-primes. So now if we just try to continue the logic of DFS, can we try to achieve it? Okay, so let's just try to think of the first prime for now. For now, what will be the answer? It will be 2 into 3, because it have only two child nodes, and the sizes are 2 and 3. But how can we return the size of tree from the parent? Because it can be complicated path as well, right? Because this is the prime node and there are many other non-prime nodes, and there can be a prime node here, or there can be other prime node here. So we cannot, and this also cannot be counted in the path, because this is the root node and we are assuming only this prime node should be in the path. But if we try to return the size, it will overcomplicate things and we cannot find the answer as well, because there can be many paths attached to many other nodes from many different subtrees. So we cannot simply directly change the logic of DFS. We have to think of other. So from this, if we try to observe more clearly, the one thing we need is, we want the subtree size in of1, not subtree size, some group of components in of1, so that we can root at every prime node and we can find the answer. So we want the size in of1. So what can we think of? It is simply DSU. So now let's try to think of more. We got that the answer is if there is only one prime. So what if we try to fix every prime node and find the answer for every root, for every prime node as path? So let's say this is the given tree, and red are the prime nodes and blue are non-prime nodes. So for this one, what is the required number of subtraces? It will be A and it will be B. And for this node, it will be three different one, and this is the same as the other one, because this path, this group of nodes is the child of this one and the child of this one as well. Because we just simply want the child nodes attached because we want the nodes attached to every prime node. So these nodes are attached to this and this both as well. So this will be counted in both. And similarly coming to this one, this three nodes one, it is connected to this as well and this is connected to this as well. So we want the size of this for both the nodes. So are we able to observe one thing? So if we're able to think more, the only thing we want is the size of components of node which are not attached to at least one prime. That is, which are both primes. Because for example, let's take this node. So what is the count we want? What is the subtract size we want? This is the first one. So the size of this will be 1, and this is also 1, and this is also 1. And now coming to this one, this is 2. So what are the nodes present in this? Both are non-prime. Because if there would have been any primes, again we would have marked it red and we will divide the whole part into non-primes. Because for every prime node we can only have non-primes in all the other subtrees as nodes. So if we are trying to think one as a component, it must all be non-primes. Only then we will count that as subtree for any other prime node. So let's come to this red one, this small red one. So for this, what are the childs? This one and this one. The size of this is 1 because it's the only one node. And for this, what is the required count, required subtree count for the present node? It is 3 because the path can start from any of these 3 and could have been ended let only this node. So the number of paths will be simply 3 into 1. So for this, the size should be 3 and not any other 4 or any other 5. So for this, it should be 3. And what does it 3 represents? It represents the size of component of only non-prime nodes connecting to this node. Because we will have this in the adjacency list of this. So when we are trying to traverse for all the childs or for all the children, for this one, the answer will be 1, the subtree size. And for this one, it should be 3. Only then we can get the correct answer. So for every node, we can use merge to merge the edges only when both are non-primes, because if there would have been at least prime, then we would, like, again we will break into like this, because this is the edge that is connected to one prime and non-prime. Did we consider it, did we merge it in our original DSU? No, because for this we only want the size of this one, because for every prime node we only want the sizes of individual subtrees, but not linked with the prime node. So hope you understand this, because for this one we want only size this one and this one. So if for a given edge, if any of the node is prime, then don't connect it, because we already have these nodes in the adjacency list. So while traversing a adjacency list, we can just simply get the size of component as size of that node from DSU. So merge only non-prime nodes so that for every prime we can get the size of child components which are surely non-prime, because we are connecting edge only if they both are non-primes, else we are not connecting this. So simply start in the adjacency list, store the both, and when we have to merge it, we have to merge only if those both are surely non-prime. So if the first node is prime or second node is prime, just continue, because we are not going to merge this in the final DSU. And if the both are non-prime, only then merge only. So let's say this is the prime node and these are 4, 10, 12, all these are non-primes. So what will be the answer for this? In the original, I just forgot one condition where we discussed the answer only when path with root as a middle node, because we discussed that it should start from any subtree of child node and it should end at other child node. But we forgot the thing that it can start from path as well, it can start from root as well. So then what will be the answer? It will be simply size of tree, because it can start from root and it can end at any of the nodes in any of the child subtrees. So it will be simply 6, because these 6 are the child. So it can start from root, it can end at any of the nodes. So, and we also discussed that it is easy to think by dividing by 2 finally, because a into b plus c plus b into a plus c and so on. So for this we are dividing by 2, but even for this we have to divide by 2, else we will lose some paths, because instead of just blindly adding the answer, Let's just try to add this one with 2 into sum. So sum is the total number of nodes in the subtree, and 2 into, because we are finally dividing by 2. So let's just simply multiply by 2 so that we can finally divide by 2 finally, which will divide by 2 this as well, and it will divide by 12 by 2 as well, which is 6, which is the correct one. So hope you understand. Let's check the code. So simply we are first using sieve to find whether which are primes or not in of n log of n. We are starting from every prime node, and we will mark every factor of that into prime as non-prime, because for example it starts from 2. From 2 we can mark all 4, 6, 8, 10 and all as non-prime, because we are able to get that number by multiplying prime with some other factor, so it is surely non-prime. So for every prime, start by multiplying those till 1 and mark those as non-prime. So in this way we can get our primes ready of in list complexity. And let's come to DSU. Let's resize parent and size and clear the adjacency list. This is just because for every test case the whole adjacency will be cleared, and we are traversing through edges, and we are merging the nodes only when both are non-prime. So if at least one is prime, then just continue. We are not merging those. And answer is 0. And travel all the nodes, because it is given that the tree consists of the nodes from 1 to n. So travel all the nodes from 2 to n, and if that is prime, because we are assuming that we are a root node, we are at the prime node and finding the answer. So stop the loop only when we are at prime. So if this is prime, then sum is equal to answer. Sum is this one, the total number of nodes in the subtree. If it is prime, then continue, because if it is adjacent to prime, then we don't have any prime, because we discussed here that we are starting from prime. So if any of the attached node is prime, then we cannot take that path, right? So simply there is no contribution from that node, even though that is connected to prime. So if that is prime, continue, because we want only one, and the only one is the root node we are taking, and we don't need any other prime node. So if it is a prime, then no need to consider it subtree as well. So just simply return. And now sum plus is equal to size of the parent, because we would have reached this only if the node is non-prime. So we reached non-prime. Then what is the size of component connected to it? It will be simply the size of parent node of it. So just sum plus is equal to size of parent of it. This loop is just for finding the number of nodes, total number of nodes in the subtree of present node. And now let's make another loop for finding the number of paths ending at one child and ending at other child. So even we are looping again, and if it is prime, then continue. If it is not, then size of the present subtree into the sum minus total one. Because we discussed in the code, when we are thinking of one child, then that child into the total number of nodes minus that child will give the number of paths starting from that and ending at any of the other child nodes, any of the other subtree nodes. So answer is equal to this present, and we are adding 2 into sum, because we discussed that we are finally writing answer by 2. So instead of just sum, add 2 into sum. So in this way we can get the answer. These both are already discussed many times. If the parent node is node itself, we have ultimately returned the parent node. So simply return the node. It'll store the parent of node as parent of parent node. And even merge, we are finding the parents of both. If they are already same, that means they are already connected. So just simply return. And the size of u is greater, then just swap and do union basis. Hope you understand this. If you have any doubts, comment below. See you in the next video.